When we do the area for this one, there's two options that we could do. If you use it in X's, remember you gotta go top curve minus the bottom curve, right? But the top curve is different. So if you use the X's, you gotta graph both those in your graphing calculator. Let the graphing calculator find those intersection points for you. And if you forgot how to do that, watch the graphing calculator video. And then what you do is you're gonna integrate from 1 to the 3.693 of the ln of x minus 0, top minus bottom there, and then you'll integrate from the 3.693 to the 5 of the top minus bottom there. That would be the 5x minus 0 right there. And that's method one to find the area. And then you do two math 9 problems, you get the 2.986 number right there. Now method two involves doing one integral. Method two is right here. So what we could use here, notice that this is always the right side, this is always the left side. And so if we go right curve minus a left curve, we could do one integral to get that area. But if you go right minus left, it has to be a dy problem. So if you solve this for x, you'll get x equals 5 minus y. If you solve that for x, you go e to the y equals x, you'll get x equals e to the y. And so if you use the right curve minus the left curve, that'll be the 5 minus y minus the e to the y. And then that means bottom to top. So here you're integrating the x's. Here you're integrating the, this should be a dy right here. But you're going to use the y's that take you across the bounded area. So from bottom to top, that's going to be 0 to the 1.307. Now, either one would work for part A, but this technique, we're going to need this in part C, that whole right curve minus the left curve idea. So we need to understand both ways right there. But just to get the area, you can do whichever one you want. For letter B, it says cross section, perpendicular to the x-axis, and we're going to do squares. And then so I had to do two separate, remember if it's perpendicular to the x-axis, that's automatically a dx problem there. And so I had to do two separate integrals with this because there's two separate s's because there's two different curves, top y minus the bottom y. So to find this s1 and this s2, it's just going to be top y minus the bottom y, except that's your ln1, that's your 5 minus x1, right? So there's your s1, your s2, and remember that's one side of your square. Remember when you do cross sections, you integrate the area of your cross section shape. So you integrate that thing squared, you're going to integrate that thing squared, and then use the x's, go left to right, that take you across your bounded area. Don't need to math 9 this problem, so sometimes they'll do that just to save on some time. They don't care how messy some of that stuff gets. If they just say write it but do not evaluate it, that's all you got to do is write that integral right there. And then I thought letter C was a little bit trickier than what we've seen before there. But here's the scenario. So imagine there's nothing in that shape right there. And then all I'm going to do now is draw on the line y equals k that divides that into two regions of equal area. So I'm gonna put like y equals k right through the middle of that thing, where this bottom area is gonna be the same as this top area. That's what we're talking about here. There's more than one way you can write this answer. You only need one of these. I'll probably go with one of these two right here. You could also do this as like a fourth way that I'm thinking about right now as well. But they want the area to be two equal regions, which means if I were to integrate from 0 to k, that would be the same as the integral from k to that 1.307. So that's why I got two separate integrals here, the integrate from 0 to k or the integral from k to 1.307. You could choose whichever one you want. If I work with strictly the bottom area, that's the integral from 0 to k. And then see, we have to go right curve minus the left curve. So that's why I'm using that thing that we talked about in letter A there. And then that equals half of the total area. Letter A, you found out that was your total area. So you could just divide that by 2 to get the 1.493. You don't even have to write down the 1.493. You could just left that as 2.96 divided by 2. You could have written that right there, and that would have been perfectly acceptable. Or if you did the bottom area, when you integrate bottom to top, you're going to go from k to that y value to 1.307, but it's still right curve minus the left curve. So that top area is also equivalent to that 1.493. You could even have set the bottom area equal to the top area. You could have done that. Another way I'm thinking about is you could add up the bottom area plus the top area, set it equal to that total area, and get that whole entire equation right there. But it does say an equation, not just an expression like this one is. So we got an equation, you gotta set that equal to that total area divided by 2. Bunny rabbit.